Problem 2, finding the length of a leg. And this one's multiple choice. The question asks, what is the value of x? Here's our triangle. It's a 45, 45, 90. We have a leg length of x, so that's the unknown quantity now. And we know the hypotenuse length is 6. Our choices are 3 times the square root of 2, 6, and 6 times the square root of 2. We're going to use the same 45, 45, 90 triangle theorem and substitute our known values. This time we're substituting in the hypotenuse length of 6 and a leg length of x, and then we solve using algebra. So we're going to find that x equals 6 divided by the square root of 2, but we need to rationalize the denominator. Remember, we can't leave a square root symbol in the denominator of a fraction, otherwise known as no hippies in the basement. Hippies, radical, basement, denominator. So just remember that rule, no hippies allowed in the basement. And we're going to rationalize the denominator. The way we do that, if you don't recall, we multiply by 1, but we get to write 1 in a way that does some work for us. So we're going to write 1 as the square root of 2 over the square root of 2. Notice when we multiply, now our denominators, square root of 2 times the square root of 2, the radical signs cancel one another out, and we're just left with 2 as the denominator. We do introduce a radical sign, the square root of 2, to the numerator, and we have now 6 times the square root of 2 over 2, but that simplifies. Notice the 6 in the numerator and the 2 in the denominator. 6 divided by 2 is 3, so we now have all of our answer in one level rather than a fraction, and that's simply 3 times the square root of 2. So the correct answer is B. Your turn, part A. The length of the hypotenuse of a 45, 45, 90 triangle is 10. What is the length of one leg? And part B, a reasoning item. If the length of the hypotenuse of a 45, 45, 90 triangle is 6, the length of one leg is 6 over the square root of 2. In order to rationalize the denominator, why can you multiply 6 over the square root of 2 by the square root of 2 over the square root of 2?